Dear students, Assalamu alaikum. In the previous lecture, we had studied about Raman scattering and Rayleigh scattering. When radiation interact with molecules, then their frequency either remains the same, which is called Rayleigh scattering, or it decreases or increases, which is called Raman scattering. If the frequency decreases, then we get Stokes lines, and if the frequency increases, we get anti-Stokes lines. Today's lecture is about theories of Raman scattering. There are two theories of Raman scattering. First one is known as quantum theory, and the second theory is known as classical theory. First, we discuss the quantum theory. According to quantum theory, which was proposed by Max Planck and favored by Albert Einstein, it considers that light consists of particles which are known as photons, and they have energy which is given by E is equal to h nu. According to this theory, according to quantum theory of radiation, light or electromagnetic radiations, they consist of particles which are called photons, and they have a specific energy which is given by E is equal to h nu, and this equation is known as Planck's equation. Now, according to quantum theory, let us suppose we have molecules and electromagnetic radiations having frequency nu consisting of photons having frequency nu and energy E strike with molecules, and these molecules are present in any vibrational or rotational level. Molecules are present in any rotational or vibrational level. The energy or frequency of molecule does not obey the energy or frequency of radiation, does not obey the selection rules. That is why it is not absorbed by the molecules, and it is scattered with a frequency nu s, which is equal to frequency nu s and energy E2. Let us suppose the energy of incident radiation is E1 and the energy of scattered radiation is E2. Frequency of scattered radiation is nu s. Now, in this case, as the molecules have not absorbed any energy from the radiations, that is why nu s will be exactly equal to nu and E2 will be equal to E1. This type of scattering is known as Rayleigh scattering. It is the first case, or it may be called the elastic scattering. As we had already discussed, it is called elastic scattering. Now we consider the second case. Let us suppose that the molecules are stationary and present in ground state energy level, a ground energy level, E naught, an incident photon having frequency nu and energy E1 photon of electromagnetic radiation having frequency nu and energy E1 strike the molecules, and the molecules absorb some energy from the photon, and they are taken from ground state, ground energy level to some higher energy level, which may be vibrational level or rotational level. As a result, the scattered photon will have a frequency nu s and energy E2. In this case, the frequency of scattered radiation will be less than the frequency of incident radiation, or we can say that E2 will be less than E1. Frequency and energy of the radiation will decrease, and this type of phenomena is known as Stokes scattering. It is a type of Raman scattering. Stokes scattering. As we had already discussed in the previous lecture, that these lines are less intense than Rayleigh lines. The third case will be that one in which the molecules are vibrating or rotating. Molecules are present in some vibrational or rotational energy level. Rotational or vibrational energy level. The incident radiations, the incident photon having frequency nu and energy E1 strike the molecules in such a way, in such a phase, the photon strikes the molecule in such a phase that it absorbs some energy from the molecule. The radiations absorb energy from the molecules and they are scattered with a frequency nu s and energy E2. As the molecules have given some energy to the radiations, that is why the frequency and energy of the radiation, scattered radiation, will increase, and nu s will be greater than nu, or E2 will be greater than E1. The increase in frequency or energy lead to anti-Stokes lines, which is also a type of Raman scattering. So the quantum theory believes that photon may interact with radiation, with molecules, and three cases may arise. Sometimes they will not give any energy to the molecules due to not obeying the selection rules, and they will be scattered with the same frequency and same energy, called Rayleigh scattering. In the second case, the photons having frequency nu and energy E1 will strike the molecules which are present in ground state, energy level E0. Now they may absorb energy from the incident radiation, and their vibrational energy levels or rotational energy levels may change. As a result, the frequency of the scattered radiation and energy of the scattered radiation will decrease, and this type of scattering is known as Stokes scattering. It is a type of Raman scattering. In the third case, when the photons having frequency nu and energy E1 strike with molecules, they will be, the molecules are present in certain vibrational or rotational energy levels, and the molecules radiations are in such a phase that they absorb energy from the molecules which are already vibrating, rotating, and the frequency increases and energy increases. This increase in energy or frequency lead to anti-Stokes lines,